Welcome back to 6th grade math. Today we are learning about equivalent expressions. Our goals for this video are to use the properties of operations to write equivalent expressions and also be able to identify equivalent expressions. Before we get started, let's review how to rewrite with a common factor. Dhamika uses the greatest common factor and the distributive property to rewrite this sum. What expression does Dhamika write? Okay, so we have to think about two things. Let's talk about greatest common factor. We learned this back in the very first unit of the course. So we need to find the greatest common factor of 27 and 45. When we learned this, there's a couple ways to do it. I like to do the prime factorization of each number and then see what they have in common. So I know the first thing that comes to my brain with 27 is 3 times 9. 3 is a prime number, so that path ends. And then 9 times 9, 2 factors are 3 times 3. So all of my paths end for my tree for 27. 45, I think about 5 times 9. 5 is a prime number. 9 is 3 times 3. Okay, now what do these two trees have in common? They both have 2 3s. So whatever they have in common, that is what you're going to multiply to get the greatest common factor. So the greatest common factor of these two numbers is 9. Now, they want us to use the distributive property to rewrite the sum. How do we do that? That means that we pull the greatest common factor out to the front, and the numbers that you multiply to get 27 and 45 stay on the inside. So that is how I know that my correct answer is choice C. If I were to work this out, the distributive property says that you take the number in front and you multiply it by both numbers inside. 9 times 3 is 27. 9 times 5 is 45. So I know that this is correct. Again, it has to be the greatest common factor in the front. Technically, okay, choice A would also give you 27 and 45, but 3 is not the greatest common factor. Okay, and then choice B doesn't make sense because 6 times 2 is 12 and 6 times 10 is 60. So that is why choice C is your correct answer. So let's talk about equivalent expressions. They are expressions that have the same value when you simplify. Okay, so for example, you see two different expressions on the screen up here at the top. You solve both of them and you get 14. Okay, so again, let's talk about distributive property when it comes to having variables. It's the same process. Then whatever is in front of the set of parentheses, notice there's nothing between, so that means multiplied. You multiply that number or variable out front by anything inside. Okay, any term inside. So A times B plus A times C. The way that you would simplify this all the way is you would just say AB plus AC. And that's as far as you could go because we don't know the values of A, B, or C. For this one, you're going to take 3 and you're going to multiply it by x. 3 times x. You're also going to do 3 times 6. And it simplifies to 3x. You just put them together. And then 3 times 6 is 18. You cannot add these together because they're not like terms. Okay, this has an x attached, this does not. This is a variable term and this is a constant, so they do not go together. That's as far as you can go. We also have a property called the commutative property. The commutative property means that you can add or multiply numbers or variables in any order. Okay, it's not going to change your answer. Here's a great example right here. And here. So numbers, 3 plus 2 or 2 plus 3, either way you get 5. and you can either write an expression as 5 plus y or y plus 5. Same thing with multiplication. Notice that it says add or multiply. This does not apply to subtraction or division. It only is for addition or multiplication. There's another property called the associative property. The associative property helps you change the way add-ins, adding numbers, are grouped, okay? And it doesn't change your sum. So maybe you want to add 4 and 2 first, then add 3. Or maybe you want to add 2 and 3 first, and then add 4. Either way, you're going to end up with the answer of 9. Same thing if you have variables. This works again for addition or multiplication, but not subtraction or division. So let's talk about practice problem 1. We have to decide, are our expressions equivalent or not equivalent? Okay. One thing that may help you figure this out is to give a value for your variable. So for this first one, 4 over x times x over 4. Is that equivalent to 1? Okay. Now, what I will tell you is when you are multiplying fractions like this, if you have numbers that are diagonal or variables that are diagonal that are the same, they are going to cancel each other out. So yes, this is actually going to be 1. Again, another thing that we've learned this year is that when you take a fraction and you multiply it by the reciprocal, remember the numerator goes to the bottom, the denominator goes to the top, that equals 1. But if you want me to prove it, I'm going to give us a value for x. Let's say x equals 2. That means we have 4 over 2 times 2 over 4. 4 times 2 is 8 on top, 2 times 4 is 8 on the bottom, 8 divided by 8 is 1. So these two expressions are equivalent. For the next one, these are also equivalent. This follows the associative property that says you can do 7 times x, then times y, or you can do x times y and then times 7. Because it's all multiplication, it doesn't matter what you multiply first. For this next one, these are not equivalent, and I'm going to show you why. Let's say that x equaled 2 again. Okay, so we have 5 minus 2. We know that that's 3. Does that equal 2 minus 5? That is negative 3. So these are not equivalent. Remember that you cannot do the commutative property when it comes to subtraction. The order definitely matters. For the second to last one, are these equivalent? Yes, they follow the distributive property. 2 times x is 2x. 2 times 3 is 6, so these are equivalent. And then this last one, let's see if it follows the distributive property. 3 times x is 3x. 3 times 8, is that 8? No, this should be 24. So these are not equivalent. See if you can find the answer to practice problem 2. Make sure you select all that apply. So, if I apply the distributive property, 2 times x is just 2x. 2 times 6y is 12y. So you can see this right here, 2x plus 12y. This one is equivalent. This one is also equivalent. Yes, it does not matter that the 12y was written first because of the commutative property. This one is also equivalent because all they did was switch the order inside the parentheses. That's okay. This last one is not, because we need to have 12y, not 6y. So you would not want to check that one. Great job today. Before you leave, make sure you can use the properties of operations to write equivalent expressions and also identify equivalent expressions. Thanks for watching.